Hello and welcome to another episode of Ken Training. Today's training, what we're going to do is we're going to be working on a residential air conditioning split system with a furnace, doing an annual PM preventive maintenance and performing a check, filling out a couple of checklists to determine the health of the system to see how well everything is operating. First off, this is in my own home. I've been living in this home for about, let's just say, 9 years. And the AC system is the original system, and it's 40 years old. The house is 40 years old. It's the original AC system. It's 40 years old. It's an R22 single stage furnace and AC unit. Both of them are single stage. And the system actually operates pretty good. I actually don't have an issue with the AC system. All I'm doing is performing an annual just to give it a good service, as well as give a training video for you guys. Now, as far as my qualifications go, so normally a lot of my HVAC background is geared towards commercial HVAC units and working on those. I don't, other than my own home unit, I really don't get a lot of residential experience. So take the training with that thought in mind. I'm not like a regular service guy that has a service truck where I'm servicing residential AC units every single day for a career. So I just work on mine intermittently. So the tools that I have are not going to be the best tools for that an HVAC service tech who's got a service van that's doing service calls every single day is going to have. So I'm just more of like a DIYer doing my own type of preventive maintenance and service. So keep that in mind when you're watching this video. So I like to use checklists for my preventive maintenance for a couple of things. It helps me know what I should be looking for, and in case I forget something, as well as I have a written documented log. I probably should have done this 9 years ago when I first moved in to have a baseline to figure out what's going on. But, you know, other priorities and other things coming up in life, and it didn't really address it, just kind of did the normal servicing. Now, I've already done some servicing to the unit behind me. So this house is a 2-story house. The air conditioning unit is one system for the entire house. It's located in this closet right here, and I'm on the 2nd level right now. So the furnace with the AC coil on top feeds into the attic, and then there's a plenum that goes to branch ductwork that feeds down. When the AC contractor went and did the original job, what they did is they put the supply registers towards the doors of the bedroom. So right now we're in one of the bedrooms on the 2nd level. Personally, I don't think that was a good installation. I think that would have been better had they installed the supply register closer towards the window exterior wall, and then allowed the return to either come through the open door or have the door cut, so this way it would come underneath the door that way for your airflow in order for the system to breathe. It would have required a little bit more ductwork, because instead of going and terminating here closer to the furnace, they would have to terminate at the exterior walls. So probably due to costs, the original contractor just does it the absolute cheapest way they can get out of the situation and still provide and say we've got air conditioning, so they put it right there. And for me to go and change it, there's 2 things that I'd have to do. I'd have to cut a new hole in the ceiling and then patch and paint this hole and texture and paint. So patch, texture, prime, paint this up. So unless I'm going through a complete brand new duct job, I'm not going to go through all that heartache of doing all that work, because then you're dealing with patching and painting on the inside too. So it's let's just say, you know, to change it, it's a project, okay? And I'm not going to certainly do that on this video, but that's, in my opinion, that would be a better installation, to have it towards your heat and cooling loads, which is towards your exterior of the house. And that way, as the air comes through the room, it has better blending to allow greater, not only that, if we supply it at the ceiling and we return it at the undercut of the door, you're getting the least amount of stratification of air within the room, so you're going to get a more blended temperature. To me, it's just, it would have been a better install had they done it that way, but they did not. So I just talking about that because I'm talking about HVAC in general for this training video. Alright, so now I want to get into the checklist and the stuff that we're going to be checking. I have 2 checklists, and you can request these checklists at my website. Let me show you that right now. Here's the second checklist. I've got it broken up into 2 different segments here. So I just call this AC checklist. You know, it's got the AC unit, date, name of the person doing the information, refrigerant and temperatures and pressures. And then here's a little refrigeration cycle. And now the top section is the refrigerant temperature. The bottom section is the air temperature with the same refrigeration cycle. So we'll go through all that. My system, just being a single stage system, 40 years ago, I think that's all they had for, that was just what they had 40 years ago. Today, you can get 2-stage systems, variable speed systems. They have a plethora of different products that you can choose from. They've got mini splits where they're trying to sell you, where you put in one condenser outside can feed 4 mini splits, which can be good and can be bad. It can be good because you can put one supply head in each bedroom and individually control that one bedroom with that one evaporator coil mini split, but then in addition to that, which they never discuss, each time you do that, the refrigerant and the condensate line have to be addressed at each of those locations, which can be a complete headache because your goal is from my perspective, your goal is to try to keep the refrigerant all within the least amount of areas as possible, because refrigerant is the portion that can leak, and what you're looking for is a sealed 100% tight system. Once you get a leaker, trying to do troubleshoot on where that leak is let's just say not fun, and sometimes you're just going to end up, you know, replacing those components. So if you have 4 units, you have 4 additional components, 4 additional points of failure, more complexity to the system. The benefit is that it gives you individual thermostat control. Well, you could do the same thing with a single central AC unit, and you provide duct zoning. So there's so many different options today in 2019 that weren't available 40 years ago. They didn't have all this fancy things that you could do in the home practically. Today it's becoming more and more practical, where people are putting more and more emphasis on HVAC. But let's get back to our system here. Again, we want to do an annual PM. I've already kind of started this and dug into it, so I'll show you where I'm at and then take you through it. As far as the furnace filter goes, this, like I said, I've been in this house for about 9 years or so, and here is the air filter. This filter was here when I bought the house. I have not had to purchase a filter in 9 years. This is what it looks like on the down upstream side of the filter. Alright, so and here's the filter itself, okay? And it's one of those washable air filters, okay? So I just take it outside, use a garden hose, and I wash it down. So lucky for me, I haven't had to purchase an air filter in years. Now, how good of a filter does this do? you know, I think it does a pretty good job. When I wash it out, you can see a lot of the lint and debris caught inside here, but they probably have better filters today. This one was, like I said, it was already here. Let's see if there's a sticker on it. There's a sticker right here, and the sticker is almost to the point where you can't read it. It just tells you the direction of airflow. I don't believe these have, and the airflow doesn't matter whether it goes one way or the other. You can swap these around. I don't think it's directional, but in any regards, this is the air filter that I have, and they want the air to go up this way. So let me go ahead and put that in. What are you doing? Did you get scared? And these filters, they just basically, once you get them lined up, they just kind of slide right in. Make sure that they don't get hung up here, and then push them back all the way into the unit there. Alright, so that filter is fine. Okay, so we checked the capacitor, we cleaned out the fan, we tried to clean things up there. What are you doing? Tigo, what are you doing? Don't you get in trouble. Okay, so now looking at the system, you can see that I've got the AC coil is right here, okay, right above the furnace. And this here's the condensate drain line. They did not put a trap in when they built it, and they just used PVC piping. Now what I ended up doing was I ended up taking a saw, cutting this PVC pipe right there, okay, and then using the shop vac here and then sucking out both ways. I put the hose going up this way so it's sucked out from the evaporator drain pan here, which collects the water. So a normal air conditioning unit is going to collect water out of the humidity of the air. Is going to be extracted. It's going to be extracted in the form of condensate. It goes to a condensate pan, which is inside this box, which is the evaporator coil, and then it drains through gravity through this PVC pipe down, and depending upon how, and now in my case I'm on the second story of the house, so there's plenty of gravity here to drain out without a pump. If this was in the basement, some systems they drain to a small condensate pump located at the base of the furnace. Then they go out. Every house is different, okay? This house, no condensate pump, just gravity drain. They did not put a P-trap in, which is not terrible because the evaporator coil is on the downstream side of the blower fan motor. So this is a positive pressure here, so a slight amount of pressure is going to bleed out of here and out with the condensate. They're also trying to keep that line clean. But because this is an annual PM, I took the shop vac and I shop vac this up both ways, sucking in going down this way and that way, and then retaped up that joint right there. So with just some black electrical tape, just so that it's not going to leak on me. Now, on modern units, what they have is they have two drain lines. The primary, and then at a higher elevation, a secondary. You're supposed to put a float switch in there. If the primary backs up, it goes to the secondary drain line, and then the float switch gets activated, shuts off it interrupts the line that goes to the compressor, which is, this is the thermostat wire that goes to the compressor contactor. You're gonna put that in line with this float switch, taking out the condenser. This way you're not going to operate the condenser unit continuously if your main line is backed up, so you won't flood out with water. It's a safety. They're only $15 and they're well worth it, and they should be installed. This thing is so old it doesn't even have the port to put it in, so it doesn't matter. Now here's the model of the evaporator. So you can see it's a Magic Chef, and this is the model number. Oh, come on. And because of that model number, the unit, actually hold on a second, we have another number over here, 048. This pretty much is telling me it's a 4-ton unit. Okay, I believe, and it's R22. What this does not tell you is whether this is a TXV or if this is a piston or a fixed metering device. I'm going to make an assumption because I can't gain access to this. This system is so old that you cannot gain access to the inside of this system. It's terrible design. The new systems, you can take a panel door off to gain access to the coil. This system is so old you cannot gain access to the coil. So I'm just going to make an assumption that this is a fixed metering device. What that means is that we're going to use the superheat method when we get to this stage of the system checking to determine if the charge is correct. We're going to use superheat for that purpose because of the metering device of this device here. Okay, and then on the high side of the magnehelic gauge, which is the top line, I got that coming down, and that is plugged into right there, which is on the upstream side of the AC coil. There is your external static pressure on the magnehelic gauge. That is at 0.5 inches. That's a half of an inch of static pressure, water column. That is a good static pressure. This unit is breathing, and it is allowing the proper amount of airflow with the fan in heating for CFM. Okay, now that I know that the unit is breathing appropriately, the AC unit has good airflow in heating mode. My expectation is to be the same thing in cooling mode, same thing with the airflow, but we'll verify that once we get to cooling. Alright, so here is the 40-year-old condenser. See if I can show you the data nameplate. I previously removed the fuse, so I need to put that back in. And I've already taken a garden hose. I keep a garden hose over there. So what I did a few days ago was I just took a garden hose and just washed the coil out 100%. So the coil's already been washed. I didn't want to have water around here when I was doing the service right now. So that is fine. So let me put the fuse in. Alright, so what you do is this has to go in either this way or this way here. Although this is poorly labeled, in order for the fuse to work, it has to go in this way. If you put it in the other way, it would not be completing the circuit. Alright, so that should start up right there. Okay, we're inside back at the thermostat. We're going to go to system cooling. Hit the mode button, go to system cooling. The house is currently 84 degrees. We're going to drop that down to 70, and that will kick off the cooling. So the fan should start up any second now. I could just hear the fan. Let's go see if the compressor started outside. And there you go. This should be feeling nice hot air, which I do feel, indicating that the condenser is rejecting the heat, which is what it's supposed to do. So let's go inside and check the unit. Wow, look at this. We're getting 5.7 amps on that supply fan. Amperage AC, 5.75. So this unit is pulling more when this unit is in cooling. Let's write that down, 5.75. Okay, so that is going to be supply fan amps, 5.75. By the way, it's not unusual for furnaces to have the cooling speed at a higher fan setting than the heating fan setting. This is a normal situation. I'm just documenting that and recording it and seeing exactly what it is. We'll try to figure out what the cooling CFM is once we fill in our data. Now that the unit has actually started, we need to give the compressor a few minutes, at least 10 minutes, if not 15 minutes. Let me get a time here. time is 2 o'clock. So I need to wait to at least 2:10 in order to have the refrigeration cycle settle down and see what's going on. But while we're here, let's go ahead and check our external static pressure. And it looks like it's come up just a little bit, and that is probably due to the fan, the supply fan, going at a faster speed. That's probably has increased the external static pressure just a little bit. So we're okay, and we're still, you know, close to a ½ inch of static pressure there. Okay, it's been 12 minutes. Let's figure out what the supply air temperature is on the cooling right now. So coming over here, I got my meter in there, and the supply air is 59.3, 59.2. So let's write that down, that the supply air temperature cooling is 59.2. Now, we want to figure out what the indoor wet bulb temperature is and the indoor dry bulb temperature is, and then we can compare these two numbers. I got my indoor, let's see here, what number are we looking at? Okay, that's dry bulb temperature, 82.3. So the dry bulb is 82.3. So the indoor dry bulb is 82.3. Call it 82. Let's figure out what the wet bulb is. Hit the mode button here. .9, call it 70. Okay. So now I'm going to go to 70. Okay, so this supply fan is, well, the supply air temperature is at 59. This is telling me, according to the chart, which you go from the dry bulb temperature, 82, bring that down, match that up with the wet bulb temperature of 70. It's saying it wants a supply air temperature of 66, okay? I'm actually getting 59.2. So if I'm getting a lower temperature than what the chart is telling me, it's possible that there's too much residence time of air, so the fan could be spinning too slowly. This fan could be increased, but that's not bad. And that is that. I can't tell you the cooling CFM. I need an anemometer, and I don't have an anemometer. I wish I did, but I gotta blow the 80 bucks and buy one. Okay, so let's move on and check our next sheet, which is this one here. We want to start filling this one out. Okay, so now we're going to fill out the A-sheet checklist. Let's go ahead and put this up here. And we're going to say that the AC unit is just number 1. The date today is 8/24/19. Name is Ken. Now these are the refrigerant temperatures. We get those outside. Let's focus on the air temperatures. We are at the evap coil. What we want is the inlet and the outlet temperature. We can get those directly off of this sheet right here. The inlet to the evap coil is this one right here. That's going to be 82.9. So the evap coil inlet, temperature inlet, is 82.9. Write that down right here, 82.9. And the outlet is going to be after here, this temperature here, that's going to be 59.2, supply air temperature. So the evap out temperature is 59.2. We write that number down right here, 59.2. And then we take 5 minus 6, that will give us our delta T. Okay, so 5 is 82.9. we're going to subtract from that 59.2 because that is the supply temperature. That's going to give us a delta T of 23.7. That goes right here. 23.7. Is that good? Yes. That is telling you that the system is, the evap coil is giving you a 20 degree, greater than a 20 degree split. As far as airflows go and stuff like that, that is pretty good. So we don't have an issue with anything on the inside. As a matter of fact, we really don't even need to put gauges on here. But let's go ahead. Well, definitely let's go outside and let's get our air temperatures, and then we'll go from there.